Hello my dear students, this is Akash SD and welcome to the ASD Physics classes. Hope so, doing good. Today we are going to solve NEET 2023 question of moving charges and magnetism. For that you should have very good knowledge of the how to find out the direction of the magnetic field when the current is going in a different directions. Okay, so let's go through the question. So student, the question is a very long conducting wire is bent in a semicircle shape from A to B. From A to B as shown in figure. The magnetic field at point P for steady current configuration is given by how much? And here how much current is flowing? Here the current is flowing I. So students, whenever this kind of question is coming, we have to break the question in a number of sections. So here what I am doing here, this one I have made it section 1, this one I have made it section 3, and this one I have made it section 2. Both the straight wires, section 1 and section 2. And this curved wire is section 3. Okay, so what will happen that here this one can be broken into the 3 parts here. No? So here please, here first I am doing like this. This is one part here. Now current is going in this direction and here point P is there. Okay, and this distance is how much? This distance we know R. This is one part. After that what will happen that here next one I am going to see the second one here. Again you can see like this and like this is here. No? Here again the current is going in which direction? Reverse direction like this. And here again this distance is how much? R, and here point P is there. Okay, plus one more part is there. Now which part is left? This semicircular part is there. Okay, so for that I have done like this here, like this is there, and here point P is there, and this distance is how much? R, is it? And here the current is going in which direction? Current is going in this direction. So this diagram we have broken into how many parts? This diagram we have broken into the 3 parts here. And as I told you, what are the section names? This is first, this is second, and this is third. Now to go ahead we should know the formulas. Okay, like here this is which kind of wire? Semi-infinite wire is there, first and second section. And this is which one? This is the semicircular coil. For that we should know the formula here. Okay students, so I will just write the formula for you. First one, if I talk about here, let's take for example if the wire is given like this. Now this wire is there, okay, and this distance is for example R. So this is called infinite wire. Which wire? Infinite wire. So due to the infinite wire the formula is used to be how much? Mu naught I by 2 pi R. Okay, where R is the distance from the wire to the observation point here. Okay, and how to find out the direction? Put your fingers straight along the current and palm towards the observation point, then thumb will indicate the direction of the magnetic field. That means thumb is going in which direction? Inside. So inside means I will write here minus k cap and here vector at point P. Now this is which wire? This is the infinite wire is there. Okay, infinite wire. After that second case, if I talk about the semi-infinite wire. In case of semi-infinite wire, what will be there here? See please here. The observation point will be just in front of one of the end of the wire here. So this is point P, this distance is R, and let's take now the current I have made it flow in a reverse direction is there. Okay, so here what will happen that here again at point P the magnetic field is given by mu naught I by 4 pi R, and magnetic field in a which direction? Again put your fingers straight along the current, palm towards the point P, thumb is coming which side? Outside. That means here the magnetic field is outside direction like this. Okay, so this is what we tell infinite wire, and this is which wire? Semi-infinite wire. At least this formula you have to remember that here. General formula as of now no need, the question requirement is not there. After that, if in case any kind of arc is there like this, current is going like this, na arc, and here what is happening that here this angle is theta. Okay, so what will happen that here in this situation, let's take radius is R. So here again at point P the magnetic field is given by mu naught I theta by 4 pi R. Okay, and here in this situation, tell me please, magnetic field in a which direction? Just again put your fingers along the current, palm towards the point, thumb is going which side? Inside. That means here how much? Minus k cap is there. And depending upon the situation, if in case this is the what to tell which coil? Quarter coil is there. So that time we have to put theta equal to pi by 4. Semicircular coil is there. Theta equal to pi by 2. Going correct? No, mistake happened. What mistake happened? because see, quarter coil means angle will be how much here? 90 degree, pi by 2. Okay, semicircular coil, theta how much here? Pi. And if in case circular coil, that means theta how much here? 2 pi. Okay, so based upon this, if we write the formulas here, that means for the quarter coil, this BP will be how much here? Mu naught I by 8R. Okay, similarly here, in case of semicircular coil, what will happen that here? This BP will be mu naught I by 4R. And if in case the complete coil is there, so in this situation put theta 2 pi, so it will come mu naught I by 2R. Now students, depending upon our question situation, which formula we have to use? We have to use this formula, na? Infinite. Which wire? Semi-infinite wire is there. And this formula we have to use here, because which kind of coil is there? The semicircular coil is there, and we are going to use this formula, and as I told you, this formula here. Okay, so let's go to the back one. Here again students, see please. So magnetic field at point P due to section 1. Formula again, which wire? Semi-infinite wire is there. So formula mu naught I by, as I told you, 4 pi. Distance how much here? R. And the direction again, put your fingers along the current, palm towards the point, thumb is going this side, inside. That means here minus K cap. Okay. Now if I talk about section 2, BP2, so here also which wire? Semi-infinite wire is there, like this here. No, one end is here. So again here also the same one, mu naught I by 4 pi R. And direction again, your fingers along the current, like this, along the current, palm towards the point, thumb is going this side, inside. That means here also how much there? Minus K cap. And after that, if I talk about this semicircular coil, so for that what will happen that here in this, for third section, if I write here, it will be given here BP3. What is the formula? We have learnt mu naught I by 4R. And the direction again, put your fingers along the current, palm towards the point, thumb is coming this side. Now the thumb is coming outside. That means here how much? K cap. Now we have written the magnetic field due to all the 3 sections. Okay. Now we have to calculate the resultant magnetic field at point P. So resultant magnetic field at point will be how much here? BP1 plus BP2 plus BP3. We have to add all of them in a vector form here. Na? So here mu naught I by 4 pi R, mu naught I by 4 pi R. We will add both of them. So it will become what here? It will become here mu naught I by 2 pi R minus K cap. Plus, due to the semicircular coil, what is coming? Mu naught I by 4R, and here how much there? K cap. Okay. Now after that we have to simplify this, and if you will simplify this, let's take here, we have taken mu naught I by 4R outside. No? So if I take mu naught I by 4R outside, that means what it will left here? 1 minus 2 by pi into K cap. K cap means, sometimes in the question they will tell K cap means pointed outward here. Na? So correct answer is here option B, and remember that this here, sometimes instead of writing K cap, they may use a dot inside the circle. Here they may use dot inside the circle. Pointed inward, they may use cross inside the circle, and they may use cross inside the circle also. So depending upon the question situation, you have to choose it. Okay.